Hello everybody, welcome to week 3 of Discrete Mathematics. And this week we're going to be learning about Boolean algebra and relations and or digraphs. With Boolean algebra, we're going to make the jump from the theoretical discussions of predicate logic and propositions to looking at more of the actual implementation of what do we do with that in computer science. And so one of the things we're going to be looking at is gates. And so I've got a little something here. So when we talk about gates, we're talking about the fundamental building blocks of digital circuits. And one of the key ones, we have AND gates and OR gates. So an AND gate, just like you learned in your predicate logic, your prepositional logic, is that you are requiring two inputs to make an output, right? So both of these have to be high. So here we have a transistor and a transistor, and then a couple resistors just for managing the voltage, and then we have an LED and two simple push buttons. So when I push the push buttons, it allows current to flow through into the base of the transistor. When there's a current applied to the base of the transistor, it allows current to flow through. And if there's any people that are into cars, that's like a solenoid in a car. When you turn the key, you're allowing a lot of voltage to come from the battery to the starter. Well, this is kind of the same thing. When I push this button, it allows voltage to flow through the emitter and the collector of the transistor. So this is actually putting what you've learned in propositional logic into actual physical form. So you can see here at the AND gate, if I push both buttons, you see this LED lights up, right? So we've got two inputs, and as we know, with an AND, both things have to be true in order for the output to be true. So if I let go of one of them, you can see the light goes off, and if I push the other one, you can see the light stays off as well, right? And then I push both and they come on. Now this other side over here is just the same thing, except for the difference is it's always on unless both switches are pushed off. Okay, so the output is inverted, right? So that's a NAND gate. Now similarly, I also have this nice little one here that shows you an OR and NOR gate, which is, as we've learned, OR, it takes an input of either one, and in case this is an inclusive OR, so we can do both. And you can see here, when I push the button, the light lights up, or if I push this button here, the light lights up, or if I push both of them, obviously the light lights up well. So just by changing the way that we arrange these transistors, we can create these different gates which allow us to use propositional logic in digital circuitry. So I just thought it was interesting. These are circuits that I built myself. I get these little kits and I like to tinker around with electronics. So I thought this was kind of neat to just show you it actually in practice. And your processor on your computer has billions of these little transistors. Now these handle higher current than what your processor does, but inside your processor there's tons of these things, and that is how the processor works in general. And you'll learn more about that in computer architecture. So that covers chapter 5, Boolean algebra. And you're going to learn some additional stuff here, but that's the introduction to it. Okay, doesn't cover everything. In chapter 6, you're going to be learning about relations and digraphs, and that's going to be kind of expanding on what you've learned in set theory. And we're going to talk about binary relations and what does it mean for there to be a relation between two sets. And this chapter will also introduce you to directed graphs, or digraphs as they're called. And that way that sets the foundation for later things in the text when we're talking more about graph theory. So it's really important that you pay attention and understand the concepts and the terminology that's introduced in this chapter, because we're going to be talking about vertices, we're going to be talking about edges, we're going to be talking about paths and cycles. So it's really critical that you understand all of these terms and spend plenty of time with this chapter. And it's not very long chapters. This week shouldn't be overly difficult or overly time consuming, but it is, again, like a lot of things in this course, it's probably new and it's foreign because you're not used to talking about things in this light. So just make sure that you're spending plenty of time, and of course, as I always preach, start as soon as you can and spend time throughout the week on the material so you're not rushing at the last minute and then trying to take the quiz or do the homework, because it takes a little bit of time to sink in, and it takes time to play around with it and look and then practice with the participation activities and the challenge activities, as well as your classmates' discussion posts, and like, okay, what is this question asking, right? So you're going to be learning about binary relations and symmetric binary relations, and of course there's tons of optional material within the chapter, so feel free to read that at your leisure, but none of it is testable, so it's good information. If you're a nerd like me and you're really interested in this stuff, then go ahead and read it, because there's a lot there, especially if you plan on continuing on your education past your bachelor degree. So just wanted to give kind of changes up a little bit and give you more of a personal video introduction to the week instead of just the text. I know sometimes it can get boring or you skip over it, so maybe, if I post a video, you might actually watch it. So good luck this week. I'm going to be, the rest of the day today, I'm going to be grading all of the work that was due, posting some of the new extra material for the week. There's some additional websites and additional videos that add value. There's also kind of went through some of the motivation here, but I'm going to try to find some more stuff to help maybe make it, why do I need to learn about this a little bit more concrete in your head. So that's it. So I look forward to the rest of this week with you guys, and I keep up the great work with your discussion posts. I've seen just phenomenal work both in the questions and in the answers, so you guys are doing great where that's concerned. So good luck, and again, look forward to working with you this week.